It had not yet dawned when the first processed images from the James Webb Space Telescope arrived, and I confess that upon seeing them for the first time, I experienced a mixture of astonishment and unease that I did not expect to feel at this stage of the campaign. It was the third week of November 2025, and we had spent months studying 3I Atlas, the interstellar visitor discovered in July by the Near-Earth Asteroid Warning System in Chile. Yet nothing, neither the preliminary spectra, nor the photometric curves, nor even the analyses of non-gravitational acceleration, had prepared me for what these new captures revealed. The object appeared as a compact point of light, absolutely pure, without a tail, without outgassing, without the slightest trace of cometary activity. What was alarming was not the absence of emissions, but the perfection of the point. The images from the James Webb Space Telescope and those from the Virtual Telescope project, obtained hours apart and through different filters, showed exactly the same thing, a nucleus that behaved neither like a comet nor like an asteroid under extreme heating. Checking the metadata, I recalled that perihelion had occurred on the 29th of October, just a few weeks earlier. Any body subjected to high temperatures in that zone should have displayed visible activity, but 3I Atlas retained the same compact appearance it had shown in Hubble Space Telescope captures months before. Such precise coincidence was, at the very least, troubling. I confined myself to magnifying the image repeatedly, examining the emission edge. There were no thermal halos. There was no fragmentation. There were no dust signatures. This was an object that remained intact even after passing so close to the Sun, behavior without precedent for an interstellar visitor of this category. The technical team confirmed that the non-gravitational acceleration continued within the already detected values, 0.22 mm per second squared, a tiny but consistent force that, accumulated over weeks, had caused a deviation of 80 kilometers from the predicted gravitational trajectory. This deviation was not catastrophic, but clear enough to compel us to discard traditional sublimation models. With each update, the sense of alienness grew. The orbit of 3I Atlas remained aligned with the ecliptic in an almost deliberate manner, as if avoiding regions of greater density or risk. Even more disconcerting, its path had managed to remain hidden behind the Sun for several weeks, hindering observation from Earth at key moments. The estimated composition, reconstructed from the James Webb Space Telescope spectra, only added questions. The model showed a mixture of nickel and iron with unusual metallic precision, almost as if it were an extremely stable alloy. Barely 4% water in the entire ensemble, a figure that decisively invalidates any classical cometary interpretation. Moreover, the estimated surface temperature, above 5,800 degrees Kelvin, explained its intense blue tone, but not the way it maintained that coloration without optical degradations. Analyzing these values, I noticed a detail that made me stop immediately. The detected jets were not oriented toward open space but directed toward the Sun. This was counterintuitive behavior. No known comet ejects material in the direction opposite to radiation pressure. It implied unknown internal processes or a surface structure capable of responding nonlinearly to solar energy. The atmosphere in the room became tense. No one mentioned it, but we were all aware that these data had sparked debates beyond our walls, growing at an alarming rate. Especially when astrophysicist Avi Loeb, always ready to explore alternative interpretations, publicly suggested that the non-gravitational acceleration could correspond to an electromagnetic engine, and even hinted that the trajectory of 3I Atlas seemed directed precisely toward the point where, in 1977, the famous WOW signal was recorded. I could not corroborate these claims, but neither could I ignore that the orbital pattern displayed a strange, almost calculated stability. Even in moments of intense radiation, the movement showed no signs of thermal stress. Only this minimal acceleration, this subtle, almost elegant push, defying simple explanations. Despite my usual skepticism, I had to admit that the possibility of standing before a body of unknown origin, not artificial, not engineered, but simply belonging to a physical category we had never catalogued, was beginning to gain weight in my reflections. I tried to restrain these ideas and stick to the data, but even the data seemed organized around a pattern difficult to classify. The technicians adjusted the spectrographs for new measurements, and it was then that I observed a phenomenon that left me speechless. An extremely narrow segment of the spectrum showed unusual coherence, as if the light reflected by the object had passed through ordered internal layers. It was a faint, almost imperceptible trace, but real. Another hint that 3I Atlas was not a chaotic body but a structurally stable system, capable of withstanding stresses that would destroy any conventional comet. As the data arrived, the date of the 19th of December appeared again and again on the screens. On that day, 3I Atlas would reach its minimum distance from Earth, 167 million miles. A unique opportunity for high-precision measurements. A window we would not get again. I stared at the orbital projection. I felt a mixture of anticipation and responsibility. I knew that public debates were radicalizing, that some insisted on extreme interpretations, but I also knew that inside the observatories, all we could do was observe, measure, and maintain calm. Because, although no one wanted to say it aloud, a truth hung in the air: if there exists a phenomenon capable of redefining our understanding of interstellar space, this is it. And the new images did not ease the doubts. They intensified them. I did not yet know what all this meant. But I knew that in that cold November dawn, 3I Atlas had ceased to be a mere visitor. Something in its light, in its silence, and in its persistence had crossed a threshold. And now, each new observation felt like a step into territory we did not yet understand. The second phase of analysis began a few hours after the completion of the initial image review. I still had before me the James Webb Space Telescope photograph, that compact, blue, and silent point that seemed to defy everything we understood about interstellar bodies. I knew that at this stage we had to focus on the most sensitive data: spectra, brightness modulations, thermal variations, and anything that could reveal the internal structure of 3I Atlas. However, as the systems activated, I realized that this session would not be a simple continuation of the first. Something in the signal had changed. I began by reviewing the photometric curve compiled over the last 24 hours. I expected a gradual decline typical of an object moving away from perihelion, but what I observed was an oscillation that matched none of the known thermal functions. The light from 3I Atlas showed small coherence variations at regular intervals, as if its surface were reacting to stimuli I could not identify. It was a response too fine to be random. For a moment, I thought of residual perihelion heat, but the pattern was too clean, too stable. It was as if the emission were modulated by internal layers activating under specific conditions. I requested the deployment of the full spectrum. The technicians adjusted the infrared and ultraviolet filters, and the screen filled with precise, narrow, sharp lines. The metallic composition dominated almost the entire band, nickel and iron, with a degree of purity that did not match typical formation models for bodies from outer regions. The most disconcerting was the ratio. It was not just abundance but an abnormal regularity, as if the internal proportions were exact, replicated with a precision reminiscent of ordered structures rather than natural mixtures. Yet I wanted to remain rigorous. Spectra cannot tell us how something formed, only what it contains. But it continued to trouble me. Beneath this metallic band, almost overlapping, appeared the signal of 4% water. Such a low percentage completely invalidated the possibility of a sublimated tail, but its presence, though minimal, indicated microdeposits trapped between internal layers. Nevertheless, these traces showed no activity. They did not contribute to the acceleration. They did not justify the jets that seemed oriented toward the sun. This behavior remained one of the greatest enigmas. Every time we reviewed the processed images, the emission vectors insisted on the same direction, inward toward the system, not outward. There was no photonic pressure explaining this orientation. As we progressed, a motion analysis alert appeared on one of the lower screens. The system had detected a new trajectory adjustment, constant non-gravitational acceleration, again equivalent to 0.22 millimeters per second squared, acting sustainably. It was the same magnitude recorded weeks earlier, but now with fresher data, the accumulated displacement already reached more than 80 kilometers. I checked the orbital graph. The adjustment did not direct the object toward us. On the contrary, it firmly held it on the ecliptic, as if avoiding greater approach. It was a fluid, calculated, almost conservative movement. Nothing abrupt. Nothing chaotic. It seemed a trajectory tuned to minimize risks. My thoughts began to tangle. I tried to focus on the protocol. I activated the light edge detectors, seeking the slightest variation in the object's optical geometry. This tool, designed to reveal internal layers or surface irregularities, had been crucial in prior analyses of metallic bodies. In the first reading, I thought the system was failing. Then I confirmed it was not. What I saw was real, an extremely stable internal edge, without vibrations, without thermal distortions, without turbulence. It was like observing a body composed of rigid layers, resistant to any stress. An object that, despite its proximity to the Sun weeks earlier, had maintained a stability no comet could sustain. At that moment, I recalled Professor Loeb's recent comments. His statements were circulating everywhere, proposing hypotheses provocative to many. He mentioned that the non-gravitational acceleration could match electromagnetic propulsion, and that the final trajectory of 3I Atlas seemed to point toward the region of the famous signal recorded in 1977. I tried to keep these thoughts out of my mind. As a scientist, I had to proceed with extreme caution. But I could not help checking the orbital projection. The line drawn by the system did indeed coincide with that distant point from the past. I did not mention it aloud. I knew such comparisons could divert our attention. But the coincidence was there, hanging like an uncomfortable possibility. Meanwhile, the James Webb Space Telescope continued sending images. Each new capture revealed a bright blue, almost perfect object. The estimated temperature remained above 5,800 degrees Kelvin, and this figure explained the color, but not the stability. No body subjected to such prolonged thermal stress should remain intact unless its composition protected it. I found in my notes the list of detected elements. Everything pointed to a metallic alloy structure or at least a material distribution imitating alloy behavior. But nature does not produce exact alloys in ordinary interstellar bodies. This thought troubled me again. We continued recording the internal jets. They were faint, almost imperceptible, but persistent. Each seemed to emanate from specific surface zones, zones we could not precisely identify, but whose repetition hinted at a pattern. The fact that they pointed toward the Sun added another layer of confusion. No conventional physical model explained this behavior without resorting to more complex internal mechanisms. I thought for a few seconds about thermal breathing systems or magnetic reorganization, but none fit the spectral data. When I checked the projection toward the 19th of December again, I felt a knot in my stomach. On that day, 3I Atlas would reach 167 million miles from Earth. It was not a dangerous approach, but close enough to allow the highest data resolution in the entire campaign. I knew that moment would be decisive. I knew it with almost painful clarity. Before closing the session, I looked again at the blue point on the screen. I had the sensation of gazing at a fragment of a larger system, a piece that had survived extreme forces and advanced with a purpose we did not understand. I did not want to think about first contacts or hidden artifacts, but neither could I force my mind to ignore the obvious. This object behaved like no other previously visited. I remained in the room even after the others left. Silence enveloped the turned-off monitors. I wondered if, in the future, other scientists would read our reports with the same mixture of disbelief and urgency we were experiencing now. I wondered if they would understand the weight of this moment. Because what these new images revealed did not soothe our doubts. It intensified them. And as we approached the critical date, the feeling was undeniable. 3I Atlas was showing us something. And we had to be ready to see it. The third phase of observation began in the quietest night of November. We had spent entire days analyzing images, spectra, displacements, and modulations, but we all knew this session would be different. It was the last before the great approach on the 19th of December, when 3I Atlas would reach its minimum distance from Earth. And although weeks remained until that critical point, something in the recent data suggested that this object was entering a new phase, perhaps more revealing, perhaps more troubling. We activated the instruments with extreme care. The main system took time to stabilize due to thermal saturation from prior observations. While the calibrators adjusted sensor sensitivity, I reviewed the latest James Webb Space Telescope images. At first glance, they were identical to the previous ones. The same blue, compact, hermetic point, without tails and without signs of erosion. But examining the internal light distribution, I noted something absent the previous night, a slight oscillation in edge coherence, a tremor so fine it could barely be distinguished from instrumental variation. However, overlaying several consecutive captures. The anomaly repeated. There, in the object's silence, a rhythm had begun to form. I requested adjusting the photometers to high-density mode. The image stabilized again, and the oscillation reappeared, this time clearer. It was an edge that seemed to breathe. I described it thus in my notebook, breathing in light. Of course, it was not physical movement, nor fragmentation. It was a barely perceptible pattern, a modulation that seemed to emanate from the object's internal layers, as if the metallic structure, that natural assembly of nickel and iron, were reorganizing in response to solar radiation or some still ununderstood electromagnetic interaction. As we observed this oscillation, an alert arrived from the orbital dynamics panel. The non-gravitational acceleration was increasing again in brief intervals. It remained the same force documented for weeks, that constant push of 0.22 millimeters per second squared, but now it appeared in pulses, as if the object were alternating between stability and thrust states. This alternation, combined with the light edge modulation, formed a pattern that fit no thermal model. I requested overlaying the emission data. It was then that tension in the room peaked. The vectors of the internal jets, those that for days had inexplicably pointed toward the sun, now showed reorganization. It was not a dramatic change, but clear enough to rule out errors. Certain jets had slightly shifted to new lengths, as if the internal structure were adjusting its orientations in real time. This could be a response to residual perihelion radiation, I thought at first. But solar intensity had decreased since late October. Yet 3I Atlas seemed to react as if sensing a different energy stimulus, one not from an external source. As the vectors updated, the jet orientation, always inward toward the system, became more defined. It was behavior that continued to be impossible to explain within traditional cometary dynamics. As the session progressed, the object's estimated temperature continued to exceed 5,800 degrees Kelvin, explaining its intense blue hue, but justifying neither the perfection of the luminous point nor the absolute absence of surface erosion. I reviewed models of metallic alloys under extreme stresses, but no simulation could reproduce the observed stability. The object seemed armored against thermal damage, as if composed of internal layers redistributing heat with unusual efficiency. Then occurred the strangest phenomenon of the entire campaign. As the jet vectors reoriented and the non-gravitational acceleration fluctuated in small pulses, the internal light edge acquired a geometric pattern. It was not a clear shape, not a rigid structure, but a transitory weave, a minimal interlacing, like nascent lines that seemed to try to organize. The pattern lasted only a few seconds. Nevertheless, it was enough for the detectors to register it. I described it immediately in the report. The object exhibits signs of structural coherence in the form of ordered light modulations, visible only during acceleration phases. That brief we've seemed synchronized with the non-gravitational acceleration pulses. It was as if both phenomena, movement and light, were linked by an internal mechanism that for the first time was becoming visible. I felt a shiver. I did not want to express it, but I knew many in the room sensed the same, that we were observing something belonging to no known physical category. Not that it was artificial, not that it was engineered, but perhaps belonging to a type of object the universe produces under conditions we do not yet understand. As I wrote the description of the light weave, I recalled Avi Loeb's words, which had sparked so much debate, his idea that this trajectory could be associated with a course toward the zone where the signal from 1977 was recorded. I continued looking at the orbital data, trying not to think about it, but the coincidence remained there, simple and static, like a line no one had asked to draw. Suddenly, the edge modulation intensified. It was a minimal moment, a flash, but enough for the spectrograph to detect an extremely precise light contraction. It was as if the object had adopted a temporary state of complete order, a moment of absolute stability that then dissipated. After that flash, everything began to diminish. The acceleration returned to baseline. The edge modulation weakened. The jets resumed their solar orientation. The blue luminosity returned to its irregular rhythm. 3I Atlas seemed to retreat, as if the window we had just observed were a mere blink of its internal structure. No one spoke for several minutes. Only the instruments continued capturing data, silent, constant, indifferent to human confusion. I remained before the main screen, observing that perfect blue point which now seemed to contain deeper secrets than we had imagined at the campaign's start. I checked the schedule. Each minute brought us closer to the 19th of December, when the object would pass at 167 million miles from Earth. That moment would be decisive. I knew that if we were ever to obtain a definitive answer, or something akin to an answer, it would be in that window. I closed the session with a phrase that, though I tried to write calmly, carried the weight of all we had seen. This object is neither a comet, nor an asteroid, nor a wandering fragment. It is something else. Something that operates under laws we do not yet understand, and whose approach represents the most extraordinary opportunity in all our modern history of observations. And I knew, finishing writing it, that we had crossed a threshold. Because in those quiet November hours, 3I Atlas had ceased to be simply an interstellar visitor. It had become an open enigma, a dark mirror of the universe. And perhaps, the first subtle trace of something we are only beginning to perceive.